Hi, everyone. My name is Emilia Muresan. I work at Modus Create. We're a digital product engineering consulting company. I'm also a JSHeroes community member. I've been working in the... Thank you. Yeah. I've been working in the industry since 2010, and I want to explore some of the lessons I learned managing technical debt along the way. I think we all have to deal with technical debt in one form or another at work, and potentially struggle with keeping it in check or eliminating it. Maybe you see it in very black and white terms. My goal with this talk is to present a more nuanced view of the problem, and by the end of it, hopefully change the way you feel about technical debt. So, what is it? What is technical debt? The first definition from Wikipedia is that it's a series of design or implementation constructs that make future changes more costly or even impossible. I prefer another definition, which states that technical debt is a metaphor, and it frames how to think about dealing with code craft, aka deficiencies in quality, by making a comparison, thinking of it like a financial debt. The extra effort it takes to add new features is the interest paid on that debt. So this term was first coined by Ward Cunningham way back in '92. He devised this metaphor when talking to his boss as he was working to explain the need to refactor a financial product, and it's ultimately a communication device that can serve us well when talking with non-technical stakeholders. So to set the stage, how does technical debt occur? So to answer this question, we'll use a chart that was created by Martin Fowler, author of Refactoring and international speaker. And this chart has two axes. The one is the total number of features or functionality in a product or an application. And the other axis is time. So one approach is to not invest any time and effort into software design of the architecture of the system. And the other approach is to actually make that investment and come up with a good or good enough design. So we have this orange line at the point where they meet. And actually, before the orange line, it might be worth trading off that design quality in order to meet time to market. But above the orange line, there's no real benefit, no real trade-off. And the short-term gains will actually disappear, and productivity will even slow down. And that orange line is basically called the design payoff line. I believe this chart holds true even in the age of AI. So AI-assisted software development practices can certainly help us save time, but ultimately, if there's no real governance, the whole venture becomes risky. It's not a replacement for design discussions, team alignment, or system thinking. Another framework that we can use to analyze technical debt is also created by Mr. Fowler, which is the technical debt quadrant. So let's look at the types of debt that are possible. The first one is reckless debt, where the development team kind of knowingly skips design discussions or tests to meet tight deadlines. And the other kind is more prudent, where the team decides to implement like a quick solution for a problem in an area of the code that doesn't really change much, or they implement a workaround with a plan to kind of refactor it later. And these two kinds of debt actually have something in common. They are both intentional and deliberate. But there's another area of whether or not it's intentional, and that's when the debt is inadvertent. So basically, the kind of debt that's reckless and unintentional is when maybe a team of inexperienced developers who are unaware of best practices create poorly structured code that becomes more difficult to maintain over time. And finally, there's prudent and inadvertent, which is an interesting scenario where you come up with a good design at the time, but over the course of months or years, you realize that that wasn't really the best choice, either architecturally or the technical choices weren't really the right ones, and then you say, okay, now we know how we should have done it. So before I move on and talk about some examples from my past experiences with each type of debt, I want to also challenge you to think about an example from your experience. Which type of debt did you most often encounter, and which one was the most kind of difficult or painful to deal with? So let's talk about the first category, reckless and deliberate debt. So for this example, I want to highlight basically a scenario where we don't have time for tests. Usually, if there are some tighter deadlines, tests are the first one being deprioritized, or they might just not be part of the team engineering culture to begin with. So let's consider this scenario. The backend side had unit and integration tests, and the front-end side did not. The focus on the front-end side was very much on delivering shiny new features, and tests were simply not prioritized. But as time goes on and complexity increased, it became very easy to break something because of the lack of tests. So in this team, we adopted a library called Enzyme, but we focused too much on testing implementation details, and our tests weren't really that valuable. If we refactored the component, even though we did not introduce a bug, we just modified the behavior, the test would fail and give a false positive. Or we had cases where there was actually a bug there, but the test didn't catch it. So we reanalyzed this choice and adopted React testing library, which improved the quality of our tests, because by design, the library encouraged writing tests that closely resemble the way the application is used by end users. So it shifted the focus to a more user-centric approach. Okay, so how did we make this change happen, going from no tests to having some clean, maintainable tests? So discussions can start in team forums. Team forums can be regular technical meetings that the team has to discuss various technical issues that relate to the project or the code base. They could be Slack channels. It's a various form, but that's really where the discussions start. Then, usually, team advocates, they can be technical leads, architects, or subject matter experts. Somebody that has a high degree of trust in the organization can take these discussions and get buy-in from stakeholders by listing the pain points and the advantages and disadvantages. So for us, we actually decided not to do separate refactoring tasks to introduce unit tests or integration tests, because we ended up creating them and they just gathered cobwebs in the backlog. What worked well for us is to write unit tests as part of feature work, even though it meant maybe estimating a little bit higher at the beginning. So we also did a lot of knowledge sharing as the team was adopting unit tests. and writing more and more of them. So we documented some practices and guidelines. So the first one was to test the common case. What does this component render? And based on the props, create multiple scenarios. The second is to test more advanced functionality. How does this component behave, simulate user interaction? Another one is to test edge cases, like error handling, for example. And a very good practice is also to test bug fixes. So basically, when finding a bug, try to see if it can be covered by a unit test. Don't test what's already tested. So we were using a third-party UI library. That UI library has its own tests. We don't really need to test the logic that relates to the library. We need to focus on testing our own business logic. And finally, if you're unsure, don't be afraid to ask a colleague. We really wanted to create an environment of psychological safety where we could talk amongst each other and share best practices and any pain points that arose. So there's a principle called make it easy to do the right thing. That emphasizes designing systems and tools where developers are naturally encouraged towards and guided towards best practices without friction. So one way to do it is to discourage incorrect or inefficient approaches by design, and this is where React testing library helped us a lot by not deliberately having a design that restricted testing implementation details. Reduce barriers to writing unit tests. I think nowadays AI can actually help with this, like AI tools like Copilot and Cursor and Claude could kind of get folks started a lot faster and ramp up with unit tests. And finally, creating documentation and regularly sharing knowledge. So one common error that we encountered, we actually created a flow chart with the common solution that we found and each step of the way. The lesson in this case is that technical debt carries interest. Moving fast was great until it wasn't. The second kind of debt is prudent and deliberate. Both the previous category and this one share the fact that they're intentional. But to me, the main difference lies in planning and commitment. In the case of prudent debt, a plan is usually set in place to deal with it, essentially. So this scenario, we had performance issues, an outdated framework. Then we were making slow progress, but the framework that we chose soon became outdated itself. And we adopted React, which through its powerful composition model and the ability to reuse components enabled us to increase productivity and move a lot faster. So again, it was a similar process like the last time, but the difference is we did end up creating tasks for refactoring because they were really necessary and we ended up prioritizing them. But we also used features, so migrating to React was also part of feature work. So for this case, we started with React because it was a very kind of complicated, high interactivity application with a lot of complex functionality. We started small with React at the DOM leaves, and we slowly moved with React up the DOM tree through a gradual migration. The only issue is the fact that we had 2 legacy frameworks to deal with. And the code was quite messy when you have 3 frameworks in one place. So the time for the migration is basically a function of the complexity of the application and the number of frameworks or libraries that you want to replace. But we did ended up successfully migrating with React. And of course, we had some practices and guidelines along the way. We had to set up scaffolding. We moved with React up the DOM tree. We always said that new features need to be built using React. And eventually, we got to a place where we could replace the entire route. This way is actually preferable if you work in a different kind of code base with different kinds of constraints. Is actually preferable to start at the route level and replace. And of course, we wanted to minimize the overhead between interaction points because we had to communicate with the legacy frameworks, and basically all of the code that dealt with this communication, this kind of boilerplate code, at one point it was going to be deleted. So it didn't make sense to have a lot of interaction point and a lot of overhead in those communication areas. And of course, making use of feature flags now allowed us to continually deploy to production. So the lesson here is technical debt can be beneficial. Not all technical debt is bad. Even though we had kind of a messy code base with three frameworks, eventually, because we chose a framework that enabled us to be more productive, and we had a plan in place, we were able to finish the migration. Another category is reckless and inadvertent. Sometimes there's teams where the experience level isn't very high. So inexperienced developers unaware of best practices might produce poorly structured code that becomes difficult to maintain. Or there's one too many cases of quick and dirty workarounds that are never properly documented. Or different patterns are introduced for doing the same thing, and lint errors are running rampant. So working in a code base with this kind of debt reminds me of the broken windows theory, which suggests that small issues, if left unfixed, can lead to bigger problems. The theory, which originates in criminology, suggests that visible signs of disorder lead to further neglect and decay. It basically reinforces a negative feedback loop. And it can be really demoralizing to work in such a code base. The feedback loop gets to a point where even more messy code gets introduced and checked in. But there's another rule in programming, which states that always leave the code better than you found it. This comes from the Boy Scouts principle of leaving the campground cleaner than when they arrived. And basically making little improvements over time can compound and can end up truly making a difference. So for practices and guidelines for this kind of debt, Dr. Rebecca Parsons suggests finding hotspots and focus efforts there. So if the code base is a big ball of mud, you need to understand where the hotspots are and which areas are worth investing the time and effort to refactor. Hotspots can be places where the code changes a lot or they're really important to the end users. So you have to analyze the application, identify the opportunities to improve, prioritize the list using an impact versus effort matrix. Maybe there are some low-hanging fruits available that are low effort and high impact. Those should be done first. Of course, take measurements before and after. So for this example, we did some targeted performance improvements. So we reduced the number of network requests. For example, we had a big dashboard, and some of the charts were simply not in view most of the time. So using the Interaction Observer API, we could determine which ones were in view and basically not trigger the request for the ones that weren't visible. We could minimize the data, the amount of data we sent over the wire. Like we noticed, we had requests that were kind of 2 or 3 requests fetching the same data, so we could refactor that. We could lazy load components, do code splitting. Like, for example, if you have a sidebar somewhere in the app that contains maybe a larger library that's a bigger size, and that sidebar is usually closed, maybe you don't need to download the library upfront. So for example, in our case, in this area of the app, we were loading 6 JavaScript files with code splitting, like using React Suspense and Lazy. We ended up with 3 JavaScript files. We shaved off 4 megabytes and saved 4 seconds of initial load time. So if I were to do things again, I would still make these improvements. What I would add here is implementing what's called a fitness function. Basically adding a check in place there at build time that measured page load time and setting a threshold. Because even though we made this improvement, without having an automated test that actually checked and validated that, that doesn't mean that the improvement will last over time. So that's one thing I would change, is to add like a fitness function for this using page load metric. So the lesson I want to emphasize here is that technical debt isn't a dead end. Basically, don't lose hope. Refactoring culture and targeted improvements can truly make a difference. So the last kind of debt that I want to cover is prudent and inadvertent. Basically, now we know how we should have done it. So there's this architectural characteristic of maintainability, and like a way to achieve better maintainability is to have type safety in the code base. So really that's the architectural side of things, but the technical choice then comes down to like which tool we use to implement this desired feature in the architecture. So this was long ago. We had 2 choices at the time, or the team was presented with 2 choices, Flow and TypeScript. Does anybody use Flow? Raise your hand. Okay, we still have some. Does anybody use TypeScript? Okay, that's what they thought. Now it's clear that TypeScript is basically the de facto industry standard. But at the time, that wasn't clear at all. And basically, both Flow and TypeScript were contenders, basically, and with the information that was available at the time, maybe this was right or wrong, we couldn't predict the future, the team and the project chose Flow. Obviously, this didn't pay off in the long run, and we ended up doing a large migration to TypeScript. Well, it was a partial migration. It wasn't enforced in strict mode, but eventually we did end up adopting TypeScript. With this case, I want to highlight that there are known knowns, things that we know. There are unknown unknowns, things we know we don't know. And the last category is unknown unknowns, things we don't even know that we don't know. So we can make plans for the first 2, and the problem is, like, things that really bite us are the unknown unknowns. And that can be related to architecture, technical choices, or even when making estimations for tickets. These unknowns make things harder. There's a saying, there's no best design in architecture, only a least worst collection of trade-offs. Over time, technologies evolved, and so does our understanding of the problem space. By acknowledging that technical debt is inevitable, we can actually incorporate some repeatable processes and practices in order to manage it. So when we first started thinking about technical debt, we used an analogy from economy. I want to take it back to economy, but from a macroeconomic perspective. And when we're talking about the economies of countries, most economists today agree that there are a set of uncontrolled variables and a set of controlled variables that determine the economic success or failure of a country. The uncontrolled variables are geography, access to natural resources, and history. But it turns out that these uncontrolled variables matter a lot less in determining the success of the economy as opposed to controlled variables, which is governance, business culture, and debt appetite. I think we can correlate this with software development as well, where we have uncontrolled variables and controlled variables. Budget or cost is something that's often outside of our control. Past technical or architectural decision is also out of our control. The evolution of technology is out of our control. But we can control or at least influence scope. By delivering a more limited set of features, we can focus on a better design quality. We can also focus on our engineering culture to be less like the broken Windows code base and more like the Girl Scouts and Boy Scouts code base. And we can also focus on debt appetite. So rather than viewing the progress in managing technical debt and addressing it on a linear path, we can instead think of it as a series of cycles where we continuously analyze the project code, the technology choices, the architecture, and the external environment, and we take deliberate action to uncover and apply solutions that support sustainability and resilience. Thank you.